Thanks everybody for joining us. I'm here. Our guest today is Lewis Parker. Thank you for joining us, Lewis.
Yeah.
I really like what you posted yesterday that we were going to nerd out on CNC things,
Yeah.
but all the nerding out is in pursuit of building the best instrument that we can. So I thought we would take a minute at the top to talk about you and the guitars you build. You know, maybe the models that you offer and what sort of customizations you offer, and with a goal toward like how that plays into your use of the CNC.
Sure.
And I can load up your Instagram if you want some pictures to add in the background, or you.
No, that's all right. Yeah, I mean, like I build, pretty much Fender style electric guitars out of this little shop here in Peterborough, Ontario. And yeah, I started out building tellies. I think probably the reason that a lot of people build a telly for the first time because it's a very easy guitar to build for a beginner builder, I'd say, in terms of the body, not any kind of contours or anything. And but there was also something else there at play for me where like I used to be a serial guitar buyer, and I spent a lot of I never actually owned a telly for more than a few weeks. Like I always just never really found kind of the right one. And so after building a couple, really got kind of obsessed with that. So I'd say that's probably mostly what I'm known for, but I do build some Strat style guitars too. And just for an old friend of mine, developed a sort of Fender student model based kind of offset short scale guitar. And so did that over the summer and got another one on order too. So I kind of, when it comes to making guitars and stuff, like I make analogies to cooking a lot, where like I'm the kind of guy who like I'll cook the same recipe exactly like on the page, like a lot of times before I start freestyling a little bit. And I think that's kind of, the approach that I take to making guitars, where it was a while for me figuring out my own recipe.
Recording in progress.
Just kind of sticking to it before kind of stepping out of that. But yeah, I use a CNC a lot for what I do, and just to kind of keep things consistent and repeatable and stuff. But yeah, I mean, within those three models of guitars, like I've got a few different neck profiles. I'll do custom ones too, but um, I'm not, like a one man war moth or something. So if somebody wants like a flame top with a, thin line with an arm contour and a belly cut and, all that kind of stuff, I'm not willing to do just about anything. But yeah, I feel like within that kind of framework, just about, I try to have a reasonable menu of options without going over the top.
Yeah.
And yeah, a lot of like kind of light relic style stuff. I don't like to really go. I'm not going for like molecular replicas of old guitars. I just kind of personally like the sort of look and feel of a guitar that doesn't have a super shiny finish, and I'm not super precious about like leaving on the couch or something like that.
Right.
So that's kind of been my approach to it, and I feel like less is more in that regard. But um, yeah, I've built a few acoustic guitars over the years too, and I'm just so painfully slow at that as much as I would really love to build more acoustic guitars, I just don't think I could actually, uh, like from an economic standpoint, I, I haven't built enough to feel like they're worth what I would need to charge in order to, to make that.
Well, that's one of the reasons I bring up, which customizations you offer, is because you can go too far down that road, and every guitar requires so much R&D that you can, get yourself in trouble.
Yeah, I had early on had this kind of funny experience where a guy brought a guitar to me that he was like starting to build himself, like a neck through guitar. He was like carving it with an angle grinder and stuff. And like I basically took his concept and like built him a guitar like that. And I don't think I've ever lost as much money as I did on that project.
Yeah,
And
yeah,
so I kind of learned that lesson early on. And um I mean, like there's uh, the stuff that I get really obsessed about with my guitars and stuff is not generally about like flashy features and stuff, but it's more like I really like the process and trying to get a guitar that plays really well and feels
yeah.
really good. And then like
Well,
uh,
but scrolling through your Instagram, it's really clear that you've got uh, a really keen sense for detail. You know, with your finishes, with the way you finish the pickup routes and everything, the post finishing. You post a lot of really high quality videos, and some of them are sort of tips and tricks, but it really focused on the attention that you're showing to your instruments.
yeah, I mean, I feel like the best advice I got from somebody was to like create the kind of content that you like to consume. And like, I'm always, if I like see a picture of a nice guitar that somebody's posted and it's like in their shop, I'm like looking at the jig in the background usually.
Right.
And like a lot of the time, you know, when you're seeing the kind of, seeing just in the background little things that people have and stuff like that's how I have gotten a lot of ideas for how to do things or whatever, where like sometimes if you just like, send somebody a message or like asking them about something like, if that message goes in the request folder or like, they are like you and really busy doing what they're doing, like, sometimes you got to figure things out by just like peeking over people's shoulders as much as you can, like online and stuff. So, um, not to say that people aren't helpful, because I've gotten a lot of great help from a lot of different people in that regard. So,
Um, well, on that note, it's just when did CNC come into your building process? And I mean, because it's clear to me that you use the CNC not because you can't do it some other way, but in pursuit of the detail that pushing the limits of precision.
yeah,
When
I
did
mean, like the first, I think maybe couple guitars that I built, I, I bought a radius and slotted fretboard from Stu Mac or whatever, and then I bought a fret slotting miter saw and or like the fret slotting miter box and that kind of stuff, and like I think I maybe did a couple guitars like that way, and I feel like it's such a thing where like it's easy to like romanticize the process of everything for like somebody that is maybe not doing it, but like I personally, after you know taking a flat board and sanding a 9.5 inch radius into it, like I was like, I don't ever want to do that, you know, and like not knocking anybody else that does it that way, but I just, for me, like I have a really bad attention span for things that don't really like get me fired up or that I'm really interested in. So there were a number of things like that where I actually quite like carving necks, and I recently carved a neck by hand, like over the summer for a kind of back burner project that I had going for a while, which was really satisfying. But the reason that I moved away from that is partially because like when I was playing a lot more guitar, I used to have a lot of issues with like overuse injuries and stuff like that. And it's just like, um, I think one time I tried to see how many necks I could carve consecutively because I had a bunch on the go, and I got like 5 ready for sanding in one day, and then I couldn't, hold a spoon at the end of the day or whatever. So it was
Yeah,
like,
yeah.
Um,
Well, that's pretty common for people later in their career to move to CNC because they have those energies and
yeah.
it,
But
it
to sort of go back to your question from before about like when did I sort of get into it? It was after like I then sort of bought a few fretboards from and that I'd had CNC, by somebody. And then I just, the from an economic standpoint, looking at that and being like, well, if I just bought a CNC, you know, it would pay for itself.
yeah, yeah.
If because what I used to do is I used to get the the outer perimeter of the neck and the fretboard and stuff all like at once, but then I would carve the neck by hand. Uh,
Mm,
so because the first few necks I built, I used templates and a router table and stuff, and um, but uh, yeah, a lot of like my process stuff, rightfully or wrongly, comes down to me trying to like idiot proof it for myself. Where like a couple times I had to remove a fretboard that I glued on because I glued it on crooked and was like, you know, even though I tried, various ways, using the drill bits as pins and like that kind of stuff for lining it up. And um,
yeah.
so that, I mean, I hadn't actually thought about it that way, but that actually kind of informed how I make necks now with the CNC in terms of like gluing the fretboard on before I do a lot of the other machining and stuff. But
Yeah.
yeah, so after doing that, I got like a hobby CNC, like one of those sort of you buy the kit and build it yourself kind of thing. And actually did some really good work with that, but I just got sick of it kept breaking. Like I
Mhm.
kept having
Yeah.
issues
Well,
with.
well,
And
I think that's a good segue into what CNC you're using now. What I've realized is that a lot of people are really interested in sort of rig rundowns of people's CNC machines because it's an expensive machine and most of us haven't owned enough of them to have experience. So when you're setting out to buy one, I think it's very valuable to hear what people
yeah,
like and don't like, or how they made the decision to get the machine, and would they purchase that machine again, or is there an ideal machine
yeah,
coming up? you know
yeah. I mean, I remember like we talked about this a little bit, and like yeah, whenever somebody asks me like what CNC I have, and then I'm like, always preface it with like, well, I'm not saying you should buy this. This is just like the one that I have. And like the advice that I got at the beginning was to buy once, cry once. And I didn't really heed that advice necessarily. My machine is not like a super cheapo machine, but it's like a pretty generic, Chinese made 2x3 machine. Pretty similar to, I think, the one that Grizzly sells, maybe probably made at the same factory, I would think. Maybe like different little components and stuff, a different controller and that sort of thing. But um, yeah, it's like a big purchase. But I mean, it is sort of like, I mean, you can't really know what you need or what you want until you have had one for a while, I think. And that's sort of why I got the hobby one and sort of did what I could do with that and then moved that along, I think, within a year of having it.
Mhm.
And I got one of these. They're like, yeah, it's like a pretty, and uh, entry level. I don't even know if I'd call it industrial, but it's like cast iron base, linear guide rails, and pretty hefty ball, like 1 inch ball screws on
Yeah.
X, Y, and like 16 millimeter on the Z axis. Um, but yeah, I've had this for probably uh, maybe 4 years, maybe longer than that. I won't get into the specifics of it, but this is the second of the same machine that I've had. I had an issue with the first one that the manufacturer actually replace the whole machine
Mhm.
after a couple years. So I know the machine, pretty well. But if I was buying another one, uh, I'd probably be buying something that has automatic tool change, just because when you're at a point where you feel like you don't want to be babysitting the machine all the time when you're running stuff, that like to have to come over and change tools and stuff like that, the time does add up if you're running the machine like almost all day or something like that.
Yeah.
Especially when you factor in, setup time of like mounting things on the machine and that kind of thing. But
Yeah.
uh,
How much do you think having the hobby machine first informed your knowledge of how they work? I've got what's essentially a hobby machine, and I got it incomplete and had to sort out the wiring, and while that's not much fun, and I don't like having problems with the machine, it has informed my understanding about how the components of a machine work. Um,
yeah, I think that's hugely valuable, actually, because and I don't think this is like specific to the company that I got this from or anything. But in the general sense, I feel like unless you're spending, 20, 30, 40, $50,000 on a machine, like you're not getting support for the machine from the manufacturer or from the person that sells it to you. Maybe, in this case, they didn't manufacture it, but whatever. Like you're not getting the level of support that you would maybe hope you would get, at least in my experience. And there are other companies where I'm aware of that every time you call them for support, like it's like $250 to call them or something. Like there's, and so having to build a machine and then have it break, and you know I one of the things that kept breaking on my hobby machine was it had this 4 conductor wiring going to the stepper motors, and I don't know if it would get like pinched in the cable chain.
mhm.
One of those little wires would start shorting. So I'd basically be going in with like a multimeter hooked up to both ends and like wiggling the wire until and like opening the cable chain, wiggling the wire all the way down, and then cutting it and soldering all 4 back together, and
Yeah.
like doing stuff like that, where it's like just having to sort of learn how to deal with that kind of stuff. And then with this machine, a lot. I mean, it can be helpful to get some insight from the support from the company and stuff. But what I've even found with this one is that like if I need something fixed fast, I need to figure out how to fix it myself, because I'm not necessarily going to pay for somebody to come down here to, so I've
Yeah.
learned how to repack a ball screw nut, which like is hours that I wish I could have back. So it's like a handy thing to be able to do if you accidentally spill it when you're taking it off, or like if you're needing to replace that, because a lot of these machines that have pretty generic Chinese components, the advantage to that is like you can get a ball screw nut on Amazon if you have
Yeah.
that Prime delivered the next day for $30 or whatever. uh,
Yeah.
but you know if you can't have that and you really have some shit you need to do, then you should, it helps to be able to, you know, I actually found with one of these where like I took off the nut and I realized that like uh, there was not enough, there were not enough balls in one of the raceways.
Yeah.
And they should, the smoothest is if they have equal numbers of them. And I don't know if it's possible for balls to like hop the track or whatever, but I found that like the ball screw the nut would work okay, but when it would change direction, there would be this sort of weird thing, and it was because one of the raceways had one too many balls in it, and it would just sort of
Uh,
like jam up on the reverse, which like
huh.
every time it does that is damaging the balls and like, that kind of stuff too. And
How did that translate into what you were working on? Like what made you go down that road?
good question. Uh, well, I at one point uh I was getting a little bit of I just was noticing a sound every time the Z would do a rapid upwards. So,
Okay.
you're cutting and then it's rapid, goes rapid up, and I would hear just like a sort of almost like a knocking sound.
Okay. Yeah.
So part of me was just trying to figure out what that was.
Yeah.
Because also the grease on the screw had a bit of like a grayish color to it, which to me was, I was worried that it was metal,
Metal flakes. Yeah.
metal mix or something. And it actually turned out that the um, what's the word? Like the little the plastic inserts that the diverters, I guess, that divert the balls back to the start of the raceway,
Mhm.
are gray plastic. So something in the grease was reacting with, and basically the gray plastic was like staining the grease or something like that,
Oh, I
or
see.
the plastic itself was kind of breaking down. But yeah, so that's kind of what led me down that road. But I've had other things where, like, on the Z axis, where I replaced the nut was because uh, you're like surfacing something and you're expecting it to look a certain way, and there was an radiusing a fretboard, and it would not be as consistent as I expected it to be, and it
Yeah.
um yeah. So anyway, there's like a number of ways that I would have noticed that, but then most recently, I took everything out and cleaned and put basically rebuilt the X-axis ball screw, and that was where I realized the having the right number of balls in each section was
Yeah.
actually critical because
But it is surprising how you used to the sound you get, and then if there's anything that falls outside of what you're used to hearing, you know,
yeah.
it sort of it raises your ears. And
Yeah, and something about like these ear plugs that like plug your ears, I feel like I seem to have a better sense of just like the the pitch or something, like, it's like when you're singing and you can't hear yourself and you're like, you see people pressing against their ear or whatever so they can hear the pitch. And I feel like it's something like that where you hear something that's wrong, and I feel like that's another reason to have a hobby machine first, is that you are going to probably crash it a bunch of times if you haven't uh, had a CNC before.
yeah,
So,
yeah.
but better to get those crashes out on something that's not, you know,
Yeah, yeah, I can sympathize with that.
yeah.
I do a lot of manual machining, and it's frowned upon to hit the vise, and I've done it a couple of times, but not anything like when I got a CNC.
Oh yeah, yeah,
Misplacing the zero or whatever, and just hit and go, and it's
yeah.
it,
I feel like you do develop a bit of a spidey sense about that, like, where there have been times where like I caught something recently where what had happened? Oh yeah, my controller is not that great with like, or I shouldn't say not that great. I am not that great. I don't fully understand the mechanism by which like you can jump to a specific line in a program,
oh yeah,
start from a different point. And so the controller has this thing where like, it prompts you to hit this cycle start every time that it'll move the X axis to where it thinks it's supposed to be, and then the Y axis, and then the Z. And then it really makes you be like, okay, are you sure you want to do this? Are you really sure? Are you really, really, really sure? And then I just did it, and it was like a neck that was basically, I was doing like the last machining operations on it, which is for me is the headstock face and the fretboard radius and stuff. And I
yeah.
just plunged what tool was it? I think it was only an 1/8 inch uh end mill, but like just crashed it straight into the headstock face.
No,
But right at the edge, and it wasn't even in the right spot. But it was basically on the one where it was like going to move the Z to where it thought it should be. And the uh, anyway, I got really
yeah,
lucky there in the sense that it plunged just to the side of it. So it was actually the collet nut that hit the headstock face.
uh-huh.
Hadn't done the finishing operation, so it actually, all was that ended,
worked out. Yeah.
that kind of
Well,
stuff.
I think we'll come back to understanding what your machine's going to do in a little bit, because that's one of the things that we talked about, and I like the way you said uh, it. Your first impulse was to say it did something,
Yeah.
but your second impulse was, well, I just didn't understand what it was going to do, because that, I hear that a lot about, sometimes it does what I think it is, but it's
Yeah.
only doing what it's told, right? So
Yeah.
at some level, it's more about our understanding about how the machine works. But we're going to come back to that. First,
Sure.
I'd like to, we talked a little bit, and I'd like for you to share about, calibration and customization, because, it's pretty common that, especially people that have hobby machines, either do upgrades, or even with a high-end machine, once you've moved it into the shop, you still need to calibrate it, get things level, et cetera, et cetera.
Yeah.
Did you spend a lot of time on your machine?
Yeah. I'm sorry to say I spent a lot of time, probably maybe more than I should have. But when I, it was one of those things where, like, again, it's like not knowing, what you need to do. You assume you get it from the manufacturer, that they've checked it over, and what they say about making assumptions and stuff. So there are various things that, um, what that I think it's probably just like my personality. But when I asked about uh, calibrating the steps per revolution and stuff, and the manufacturer had said, "Oh yeah, we do it all with like a measuring tape, or like a 3-foot ruler or whatever."
Yeah.
Um, and like I get the theory behind that. So basically, what most people say for hobby machines and this kind of stuff is like, the longer the distance you can calibrate over, you're reducing the amount of error. So let's say you are using a V bit and a 3-foot, 36-inch ruler or something, and you have told the machine to move 36 inches, and it's pretty close. If you get within, I don't know, if you get within, let's say, less than a 64th, even, let's say you get within, I don't know, 10 thousandths or something like that across 3 feet.
Yeah.
Like, if you divide that per inch or whatever, that's not a significant error at all. And I also recognize that most people, or no, I shouldn't say most people, but a lot of people using, the hobby grade CNC routers and stuff. It's like, you're engraving cutting boards and like doing stuff where it's like, if it is a little bit bigger than you need it to be, like, you're sanding it with 120 anyway. So um, I definitely tried calibrating it like that at first, and just in my brain, that really didn't sit well with me. And because it's pretty easy to tell too when you're like, what your 12th fret distance from the nut should be, and then you throw that same 36-inch metal ruler on it, and you realize that it's not where you want it to be. That
Yeah.
problem, and I hadn't really found any great, what I thought was a good method for doing it. So the the first, I saw somebody do something similar on YouTube, where I get all of my great ideas, I guess. But this I was sort of iterating on something that I saw somebody do, where um, he was using gauge blocks, and you can get a pretty cheap set of gauge blocks on Amazon or something. I think mine are Wen brand, like that WEN, that make the black and orange
Yeah.
holes or whatever. But uh, yeah, so basically, what I ended up doing the first time I did this was I wrung together 10 inches of gauge blocks with another gauge block rung onto the end at a little bit of an offset.
Mm-hmm.
And uh, really carefully tried to basically, I used like a clamp to hold it down on the CNC table. So the reason you have the offset one at the end is just so that you can basically pick up one edge and then pick up the next edge without changing direction. So you're not introducing any of the backlash into it.
Uh-huh.
Um, but I will tell you from experience that a 10-inch, line of gauge blocks that are rung together is very hard to tram into the machine and also to clamp down without having them break apart. So after doing that a few times, the last time I did it, I picked up this baby, which is a 12-inch gauge block. And basically, like going back to the like, you want to have the greatest distance to calibrate across. If you were to take like even like the biggest gauge block in most sets is 4 inches, I think, right? So if you went across 4 inches, I don't know, oops. They come with a little certificate usually telling you like plus or minus. I know I'm telling you this, I know you know this, but
No, yeah. This is perfect.
but basically, the gauge blocks come with a sheet. So it says, okay, this is 4 inches. We guarantee that this is 4 inches, but when you nerd out a little bit on metrology, you know that there's actually no such thing as like 4 inches. It's like 4 inches plus or minus something.
Yeah.
So, on this one, the 4-inch block is -8 microns. So, if you were to calibrate to that and say that it's 4 inches, but it's actually -8 microns, and then you're taking that across a greater and greater distance, you're, multiplying that error larger and larger.
Right.
8 microns is not significant, but when you're adding together more gauge blocks, even to like make a bigger one, what I was doing when I did that was I added up all the tolerance stack of every single block I was using and used that as the calibrating value. Just to, and then from that was able to then machine things like, for instance, tuner hole spacing and stuff, where you're just drilling along a line, where like as accurate as my calipers can measure,
Yeah.
to a half thou, I was able to hit that, which on tuner holes being at an angle too is even better. So but it was just a huge pain in the ass to do it that way by ringing them all together and stuff. So basically my method now is that I use this big ass 12-inch gauge block with one offset.
Mm-hmm.
And I made a little uh here somewhere. Basically a board that has the spacing of those holes in the gauge block. And so the X and Y axis, I could bolt it down, tram it in first. To basically, try to make sure that the precision ground short end of this is actually in line with
Square.
the, square to the axis of the machine.
Sure.
So that generally just involved a little bit of tap, tap, tap with a hammer here and there and checking again. And that's usually, using a test indicator to just kind of sweep along the end of it. So that definitely made it a little easier with the 12-inch block. And if anybody's feeling like they want to be that pathological, the 12-inch gauge, 10 and 12-inch blocks from Shar's tools are actually really reasonably priced compared to like the Midatoyo ones or something.
Oh yeah.
A Midatoyo like 12-inch would probably run you like $800 or something. I think that was like under 150 shipped, so not too bad.
Yeah.
Um,
No, this is good, and I hope this is not discouraging people. I think this is informative. When people are considering getting machines, that these are going to be things that eventually arise. Uh, was that just nudge per revolution slightly to get to?
Yeah, well, and one thing that was really interesting about all of this, I think we talked about this a little bit too when we chatted before, but uh, I mentioned that this machine was a replacement for another one, and since I got this one, like this one didn't sound the same as that one did, and I just sort of chalked that up as to, like, different machine, different different tone kind of thing, and in sort of we'll maybe talk about this too, but in retopping the table and sort of making it a bit more purpose built to like making my guitars specifically, I went down a rabbit hole that I go down off for my own peace of mind, letting a genie out of the bottle that I can't put back in it. So one of the things that I learned when it was after calibrating the machine, and like, the machine jogs in half thou increments. Like that's as small as I can jog with the pendant. Um, and when you're calibrating your steps per revolution, it tells you the pulse rate, which as I'm talking about this, I'm realizing that I'm like peeling back a lot of layers of an onion really quick, maybe. But
Oh,
that's
good.
stepper motors, typically they have 200 steps that they have, and if you divide a circle into 200 pieces, it's whatever 1 point something degrees per step, and that's not sufficient to really do anything that we needed to do in the sense of like moving a very small amount. So what you'll hear the term micro stepper, and basically what that means and like what these motors do is like there's a driver. Sometimes it's built into the motor. Sometimes it is a separate box that the motor is plugged into. But basically, the controller will send a certain, you know, pulses at a certain frequency to the driver, and then the driver is sort of like Google Translate, and it translates the uh, pulse rate it's getting from the controller, and it's basically subdividing those 200 steps into you can set it to all different subdivisions. So it could be 1,000 pulses per revolution, it could be 2,000, it could be 3,000, it could be 3,200. Like it has a big thing with dip switches that you got to change the dip switches to match. You basically need the controller and the driver to match, and so what I found with this when I was trying to see if I could get if I could change the pulse rate to get a higher resolution, because I was having this thing happen which I thought was a result of just the fact that you can only jog in half thou increments. But it would be like, if I was, say, picking up an edge with an edge finder and jogging in half a thousandth at a time, and sometimes you'd see like click, 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 and the machine didn't move at all. And then on the fourth click, it like jumps a little bit. And I always just wondered if it was like a rounding error, because like the axis resolution uh, in the settings was, I don't know, 0.0002 something. So 2 tenths and change. So I was wondering, well, could I change the pulse rate and get that, you know, uh, change that number, basically change the resolution.
Yeah.
And then I realized that the driver and the controller were set to two different pulse rates, which means that basically the machine was sending 2,000 pulses per revolution, it thought, and the driver was interpreting those 2,000 per revolution as 1,600 per revolution. So the discrepancy of 400 steps per revolution. And when you have stepper motors, you got you might hear the term closed loop versus open loop, or just like, and what a closed loop stepper motor usually means that there's an encoder which is tracking where the rotation of the motor is at any given moment. And then the driver has a tolerance as to how far out of whack the motor can be. And if it gets too far away from where it thinks it is, it'll throw an error saying like a position error or something like that. And I would get that happening sometimes, only like, say during an adaptive clearing or like a high-speed machining type thing where the machine's maybe doing some kind of quick turns and stuff. And so anyway, what I realized was that it was basically the pulse per revolution from the controller versus what the driver was set at was close enough to just make the machine kind of jerky and like not run very smoothly. But
was it constantly compensating because the encoder?
yeah. It would be like, you hear about like servo motors, like hunting or whatever. And this is a similar kind of thing. It's not a servo, but basically, yeah, what was happening in reality of like when you're jogging like that is like it, if you keep jogging and jogging and jogging a specific amount, and the machine is expecting, the driver and the controller are, not speaking exactly the same language, eventually in that rotation around of the motor, there's going to be a point where it overcorrects for when, because it's not that like, it's accumulating error as the motor is going around. And then eventually it gets to the point where it gets close enough that then the driver will compensate
Right.
for it being off. And so that's why it then jumps. So you go click, 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 which should be 1,000, 1,500. Nothing happens. And then that fourth click, all of a sudden it jumps forward by that amount on your indicator or something. And then it was something I didn't know I needed to look for, but then, end up, getting to figuring out that that's something I also had to check. And so once I put that back to the way it was, then the machine actually ran a lot more smoothly, and I haven't experienced that same issue. But
yeah, so if it had been like standard stepper motors without the encoders, you would have noticed because it actually would not have gone the distance you expected. But in this case, it was sort of hiding the mismatch by over.
I mean, and because the thing is it's like if it on a regular stepper motor, if it skips steps or something, or like you will just see that in the machining too. Like you'll see that happen where like this was close enough from what it was sending to what it was expecting that it was able to compensate a little bit. But it just like even the surface finish improved like when I changed those values to be matching, because the machine was just no longer like it was just moving in one direction rather than maybe like going and then adding or subtracting little bits at every move or something.
Yeah.
Okay. I'm wondering, can I ask a question?
Yeah,
absolutely.
First, I'm wondering, Louis, what your background is, because I mean, a lot of what you're talking about sounds technical. Not to me, because I've built 4 CNC machines before, but it goes back to one of your original, statements about, buy once and cry once.
Yeah.
A lot of what you're talking about, I suspect that someone just buying a commercial one of these and using it is, this knowledge that you have, that I have, that James has, of, when something malfunctions on the machine because you either built it or you've, it's a hobby machine that you've had to sort of piece together, how each of them functions. So it occurs to me, is that even good advice for a luthier, to buy once, cry once? Because will you ever get to know the machine? Because if you pay $20,000 to $30,000 for like that goddamn Tormach, which I would absolutely love to have. You know, if something went wrong on that, I paid that much money, I'm calling Tormach and saying, get your ass over here to fix it. You know, but of course, you know, like you say, it's better if something goes wrong that you can do it in the day rather than waiting for weeks to go by where you can't do anything with the machine. So I was also wondering what your background is, because you seem, you know, highly knowledgeable of this. Is this just from you working on that hobby machine that you've learned all this, or do you have an
Yeah,
engineering background?
I do not have an engineering background. I'm a music school dropout. So yeah, everything that I've learned with regards to this has been just like out of necessity, I guess. And I think, I mean, you know, as far as to whether it's good advice to buy once, cry once, I think that's an excellent point, and definitely something to think about. And I think people need to kind of know themselves because, you know, I got the hobby machine because of the price that it got, you know, it got me in the door with something. And, you know, when I bought this machine, if I would have gotten the ATC version of it, it would have probably doubled the price too. Um, and yeah, I think actually, I do think that you make a great point, and I don't know if that's good advice to buy once, cry once, because if you unless you are, you know, willing to unless you're willing to learn and make your mistakes on that machine, I guess. Like, it probably depends on where you're coming from in the sense of like if you have a background in it and you've, you know, worked in a shop using something and you kind of know what you're in for, then, you know, maybe buy once, cry once is good advice. But I think that yeah, what James and I have talked about with regards to this before too is kind of like I think a big question that sort of kind of needs to be answered before any of this stuff with regards to like what machine someone should buy or shouldn't buy or whatever is like, what do you want it to do? Or like what, you know, because I think there's plenty of great applications for having a machine just being, you know, just hogging things out. And if you're wanting to be like, uh, you know, hand finishing, you know, your necks and stuff, and you're just really kind of rough carving them on the CNC or like that kind of stuff where like, you know, none of what I talked about probably really matters in that case. Maybe it does, but um, I think like what uh, led me to kind of learn all of this stuff was that I wasn't happy with the results that I was getting on a specific thing. You know, like let's say I was having issues with, you know, as I'm sure many people do, with two-sided machining on necks and having things feel like they're not quite lining up exactly the way that I want them to. And, um, you know, after kind of doing the thing and trying to deal with support of the company who sold me the machine, um, a little bit of the attitude uh, was like, well, you're just asking too much of this thing that, yeah. And like, I've notably just not said who I got the machine from because I don't want to be like dragging them or whatever. And, you know, I don't mean any disrespect to them or anybody else in that regard, but it was just something that like what led me down the path of like calibrating the machine in that way and like trying to even just learning how to do that. And like, you know, somebody telling me like, well, you know, the, I pick up my G54 every day with a test indicator because I don't trust the homing sensors. And I was just trusting the homing sensors, and the support for the company was saying, oh, well, the homing sensors are very accurate. You know, the spec on them is like accurate to 2 microns or something. And it's like, yeah, I mean, the sensor itself, I'm sure is, but like when you add in all the mechanical stuff and like you don't know if you have backlash or not or how much, then like, you know, when I after somebody told me that and I started picking up my G54 the same point every single day, and writing it down, you start to see, well, okay, well, the y-axis is usually within a thou or a half thou, and the x is, could be 2 thou or 2.5 or whatever. Like, just like what led me down this, like getting as intense about it, was basically not getting the results I wanted from the machine that I had, and then somebody telling me that my machine, uh, you know, is what it is, and me just sort of not being happy with that answer, and just like what it really sort of taught me about uh this, and the way that I use it and that I want to use it and the results that I want to get, is just that, like, uh it reminds me of something I heard somebody say, and I can't remember who, but it was, something along the lines of, like, you're about to do something important, like, cutting some purfling miters or something, and you're not sure if your chisel is sharp enough. Well, how do you know it's sharp enough? And it's like, well, it's because you just sharpened it. That's how you know. And in this case, it's like, well, how do you know that the part is where you think it is? And it's like, well, because you checked, and how do you know that it's going to cut something the size you want it to cut? And it's like, well, you got to, there are a ton of other ways to calibrate the machine too, I will say, because, calibrating it with a 12-inch gauge block or whatever is all fine and good. But, if you machine a climb cut around an electric guitar neck in hard maple, well, you got the grain direction running out in one direction on one side, and the opposite of that on the other. So if you think you're going to get a perfectly symmetrical thing when you're cutting it like that, the machine, as soon as you get cutter engaged with whatever it is that you're cutting, all of the other variables come into play. And so I guess for me, it came down to, like, with the two-sided machining and all that stuff, and feeling like things weren't lining up. And it was a bit of a light bulb moment for me, where it was just like, well, if I can try to know and control every variable that I'm aware of and that I can actually test and verify, then I know that it's not the machine. Like, it's easy to be like, oh, well, the machine isn't supposed to be able to do that. And it's like, well, actually, like, if you had a good edge finder indicator in a hobby machine, with a DeWalt router hanging off of it, like, you can do some really good work, but you got to just know, you got to know where things are, and you got to know the limitations of the machine. And unless you kind of, like, investigate it and dig a little deeper, you won't know. So if you're trying to get, like,
Another question, if you don't mind. What are some of the things that you think that in building the guitar, what are the things that you think the CNC machine is invaluable for, and you would never use anything other than the CNC machine because of how, either accurate or well it does? And also, what are the things that you wouldn't bother doing on a CNC machine because it's probably, more time consuming to do on a CNC machine?
yeah. So, I mean, I guess, in I do a lot with it, I will say. And there are some things that they're not great for, like drilling deep holes. Not a real strong suit of a CNC. I had a bit of a personal conflict with my drill press a little while back, and I sold it on Facebook Marketplace and never bought another one. So I still don't have a drill press. So I actually do use the CNC for drilling all that stuff, but I am going to get another drill press again at some point. But I think, like, it's tough to answer. Like, if I'm answering that question for myself, I think, like, I would probably not, cut fret slots any other way. I don't think, just because of the way that, like, of the kind of process that I use now. If I had, like, one of those gang saws or whatever that Stu Mac has, that just, like, run fretboards through or whatever, and it cuts all the fret slots at the same time, like, that would be sweet. There's a lot of, like, I think it's tough to, like, make the claim for, like, a production shop that, like, a guy, like, standing at a shaper with the right jigs couldn't, like, crush out more stuff than a guy standing at a CNC could do. But I think for me, like, I still do, like, roundovers on bodies and stuff with a hand router. I've done it on the CNC before, and, like, I don't know. It's one of those things that like it it's one extra tool change. I also like, before I route it by do a round over by hand, I like do most of my sanding on the sides of the body too. So like I don't want to have to sand the sides of the body and then also sand the round over that I just like spent extra time doing on the CNC to be like perfect or whatever. Like it's easier to do that stuff after the fact.
Now,
Um,
I have one more question because I've seen it on one of your videos on Instagram. I suspect I know some of the answer. You CNC after the finish is done.
mhm.
Why is that?
Yeah, well, so one reason is that like sanding is just made easier at every step of the way. Like usually what I try to do, the sort of I guess before doing the sanding after the finish, like one thing I would do would be like before I cut out the body, I would do most of my sanding on the top and the back before I cut it out. Because I just find it's easier to run that through the drum sander, and then it's way easier to just use the random orbital to sand like a rectangle than it is to try to not you know over sand the edges or whatever. And so it's easier to sand, a flat rectangle with no holes in it. So I would sort of do my uh, machine the pockets after the fact. So I would just kind of have to touch up from handling the guitar and maybe doing the roundovers and stuff like that. But uh, now the way that I do it with routing after the finish, yeah, it just makes sanding to prep for finish easier. It makes sanding during finishing easier. It makes polishing easier. Um,
And the big question is, how do you register it? I pin register it to my bed, but once it's finished, there's nothing, there's no loose bits I can cut away afterwards.
Yeah, that's definitely, yeah, I get asked about that a lot, and tellies are lucky, it's a good thing for that where you've got like generally like on anytime I've index pins for something, whether it's a neck or a fretboard or body or something, my first instinct is to like use a hole that already exists. Like I don't want to have extraneous holes and stuff. I as much as I would love to do it exactly like Leo did it, and fill the little dowel holes from the templates and stuff, so that to make everyone happy. I try to use holes that already exist on the part. So I do have two pins on. This may be a good time for a little show and tell here, but
Yeah, no, I think this is good. It's a good time to shift from the discussion about the machine to your process.
yeah. So I mean, uh, yeah, this is a fixture that I use for machining a body
Oh,
before and after finish. Yeah, so basically, this is the fixture that I use for machining the body before and after finishing. And so on a Telecaster body, I use two, like the outer E-string holes where the ferrules go. And then I do add a pin that just gets hidden under where the neck plate is. So I've got a body over here where you can see on the body where that is. So we've got a 1/4 inch pin here, and then I just
Hey, Lewis. Just really quick. Your audio just got really quiet.
thanks, Ian.
Yep.
It's just something that is a bunch of. That's one thing. Just dumped a bunch of sawdust out from the jack there. Um, that's one thing that's kind of annoying, is having to drill the jack first without routing the cavity. But I've just marked on the drill bit there how deep I need to drill, and yeah. So on the back of the body, I'm just using these two holes here and a hole here to register it. Um, and when it comes to like needing to reference that again, when, a couple weeks or whatever have passed, that's where really kind of the fixturing and like knowing where things are, and like knowing like having drawn everything out for your fixtures, and like being able to pick up the same point a year from now, and know that your machine, the center of your spindle is right in the center of that bore or whatever. So like maybe I'll bring this over here. Are you guys hearing me there?
We didn't there for maybe 20 seconds.
Oh, okay. Yeah, I just hadn't said anything. I was like, just wanted to make sure
Okay.
that a breaker was turned on over here.
Yeah.
But yeah, I mean, I hope that answers your question here. I'm gonna just bring the camera over to this fixture again, and so you can see, like, theoretically, my G54, like my X and Y 0 is set to the same point on the table. So everything is drawn out in these fixtures. So one way that I just ensure that whatever part I'm machining at that time is, like, I've gone into the CAD, and I'm a Fusion user, so like there's this. If you hit inspect or whatever and click on some geometry, and it tells you the coordinates of it. If you're in the manufacturer workspace, what's kind of handy is there's a little drop down menu that says you can make it whether it's just like giving you the coordinate from the design or from the active setup in your WCS. So if you select your active setup, like I've written on my fixtures that this bore here is at X 15.25 and Y 12.7274. So if I'm about to machine a guitar that is lacquered and whatever, and I don't want any surprises, then when I put this fixture on here and I use my edge finder to pick up this hole, and I find the center of it, and then I'll use the keyboard on the controller for the CNC to, once I pick this up and set this to be 0, 0, I'll then change the X value to whatever the coordinate needs to be. Same for the Y value. And then I know that, whatever happens, that I've set the 0 on this fixture. And that's where it kind of helps to have some, and you'll see on all of these, I've written down various things at different points. And in a perfect world, you would have switch this video around here. In a perfect world, you would have when you pick up your 1-0 point, everything will match up. But as I was just talking before about having done a bunch of calibration and stuff, I sort of noticed an issue after I'd machined all of the locating features on this table. So I had to do a little bit of reverse engineering after I had recalibrated the machine. And so not everything is exactly where I wanted it to be because I machined some fixtures already. So while I was able to remachine some of the index holes and index features on the fixtures themselves, I did have to like go in and change the CAD and sort of shift some things around to match the reality of, basically had to use an edge finder to like verify actual locations. If I were to, pick up the 0 from here, which is where it's actually supposed to be, in reality, some things had actually shifted. So that's why phenolic sheet is pretty expensive. So because I already cut those fixtures, I thought, well, I better just try and figure out a way to make it work. So that I'm kind of doing it that way for now. But
is that G10 phenolic that you're using for your jigs?
No, this is G10. I think is if I'm not mistaken, has fiberglass in it.
Yeah.
Which is, I mean, this is CE phenolic, so it's basically just phenolic resin and canvas, I guess.
Canvas, yeah.
And it really, like, the dust is like mustard yellow, and it's basic, as far as I understand it, phenolic resin is like formaldehyde, basically. So it's really nasty stuff to machine, in addition to being really expensive. But yeah, the CE grade is a little bit more stable in the sense of, like, it doesn't move as much after you machine it. For like the top of this table, because it's bolted down to a sheet of CE, but the top is XX grade. And I think XX, at least as far as McMaster car goes, is the cheapest grade. And that's just like sheets of paper and phenolic resin. But yeah, G10, I feel like would be a even more serious health hazard, and would probably, the CE stuff is really not kind to carbide tools, and I'm sure that G10 is even worse. So,
and I'm assuming you use this rather than something like MDF or plywood because of the stability to humidity changes.
yeah, and also just like to be more permanent, I guess. Like I've made some fixtures and stuff that locate on there, just like a Baltic birch, sheet or something. That if I'm just going to be doing the old tape and super glue thing, there's no need to be doing that on a phenolic sheet. But for the vacuum fixtures that I make and stuff, that's, I guess, another thing, is that the phenolic is it doesn't pass vacuum through it. So it is, yeah, it just is a bit more stable, and like, there's nothing wrong with, like, I've done a lot of fixture boards out of Baltic birch and MDF and stuff, and it just, but I'd been angling to make this system up for a while, and just wanted to do it in a way that I wouldn't have to be redoing it.
Can we talk about the system that you designed and what your goals were?
Yeah, sure. Yeah. So, I don't know if, I guess maybe I'll leave it on this camera here. But yeah, the table that it came with was just like a pretty standard, like PVC vacuum table for doing like pass through vacuum, or high volume, low pressure, which would be like a shop vac, or something like that, where you put an MDF spoil board that has gasket around it at the bottom, and you've machined off a little bit of the top and the bottom to make it a little bit more porous, and it basically, it sucks a huge quantity of air, like a lot of cubic feet per minute, through the board, and the vacuum pressure that it generates is not huge. But if you're doing cabinetry or sheet goods, or the aforementioned cutting boards and stuff like that, that would probably be good. I've done that with guitar bodies and stuff too, and it worked all right. But vacuum pressure and like the amount of force holding down the part is a function of the surface area of the part, combined with the vacuum pressure. So with the MDF spoil board and high volume, low pressure vacuum source, you're maybe getting, a shop vac might be 5 inches of mercury. Most of the like commercial, like a black box or whatever, which would be like what they would sell with this machine, for instance, they would maybe get 9 or 10 inches of mercury. It's not exact, but an inch of mercury is about half a pound per square inch. And so if you only get 5 inches of mercury, you're only getting 2.5-ish psi. Just off the top of my head, I know that like my fretboard surface gluing surface is like 30 inches square. So, you're not getting a ton of, weight holding that down or whatever. So what I did was I took the PVC table off, and I based this system on the one that the guys at Frank Brothers have on their Haas. And basically, the idea is that there's vacuum source hooked up underneath the table. That's a high pressure, low volume. So it's maybe where a shop vac or a bigger vacuum pump might be like 200 CFM and let's say 10 inches of mercury. This is like, 6 CFM, but, 25, 27 inches of mercury. So a lot more pressure, which for smaller parts, higher pressure is better. So after, getting this phenolic sandwich glued on to here, basically I designed really just two pretty simple zones. One zone is for like bodies and pickguards and stuff like that, which is here, and the neck zone, which is beside it. And it's sort of like a pallet system. So I'll flip the camera around here to show you.
Lewis, it got really quiet. Are you talking?
Sorry about that. Yeah, I was not talking a lot, but I accidentally muted myself.
No worries.
I just fired up the machine here just so I can like jog it out of the way. Show you a bit better with this camera angle here, but so this is the body zone here, and I've used these. Basically, there are pins in the table, and then in the bottom of all the fixtures are these hole liners. So the bottom of the neck fixture, whatever, they have those in them. And so one of these has a diamond shape, so it really is only making contact from the two sides of the inside of the sleeve. This one here is round, so it is the pivot pin, I guess, for lack of a better explanation. So this pin doesn't, this pin sort of locks in the position here, and then the other one locks in the side to side. And then each fixture that goes on here has gasketing in the top and various holes and things. And so the vacuum is being pulled through the bottom, and is holding the parts being held down on here. And just to try to be more efficient with material here, like you can see, this is what I would use to machine, say, like the top of the neck before I glue the fretboard on. So got that, but then I also have pieces that sort of go on top where topper for the topper, I guess, where when the neck is being carved and stuff, this pod will hold the heel, and that will hold the headstock. It's one of the things that I do with my necks is that I glue the fretboard on before I carve the back profile, and then I will once I've carved the back profile, I will flip it over and do the final like fret slotting, the finishing of the headstock, finishing of the fretboard, the nut slot, all that stuff as like the very last thing that I do. And so this system I used to just use tape and super glue a lot, to be honest. Even doing, I didn't use tape and super glue on finished guitars for what I would think would be obvious reasons, but the first few post-finish bodies I did using the the old table with an MDF or Baltic birch fixture that I was pulling low pressure vacuum through. Where for a body, because you got enough surface area there, and by the time you add the locating pins in, like if you were just had something like set down with nothing to hold it from moving side to side, I would be pretty scared to machine that. But when you add pins, you're changing it from like moving side to side, which would just throw it off, to like you'd have to have it get pulled straight up, which the cutting forces just aren't really doing that. So like anytime you can add pins into something, even when you're doing tape and super glue, that's how I was able to still get really good results doing that. This just makes it more efficient, a little bit faster to machine things. Because whereas before, like if I'm using the tape and super glue, I didn't really use activator for that because I like sometimes you just can't get it down in time or something.
Yeah.
So what I often do with that is I have like my buckshot bag or whatever, birdshot bag, and I would just put the part on without any activator and just put some weight on it and set a timer on my phone for 5 or 10 minutes and just let it set up a little bit. So if you're adding, you want to do a few necks in a row or a few bodies in a row, and you're having to do that every time, getting all the tape lined up and on both the table and the part, and then throwing some weight on there and waiting a little bit, and that adds up over a day if you're wanting to do several parts in a row. We're doing it this way, just on and off, really quick. So now I can do a few of the same operation on a few necks before moving on, and it just makes things a little more efficient. But
Yeah.
And have you changed to the Masso controller? Is that what I see over your shoulder?
Masso came with it was an upgrade like when I bought this machine, but I've only ever had it, so I didn't add it myself, but I do quite like it. Yeah, I like to be able to see a preview of what's about to happen, based on what we talked about before a little bit about just like the machine. For better or worse, the machine generally does exactly what you tell it to do. It's just if you don't realize that you told it to do the wrong thing, then you could be in for a surprise. So yeah, I have no complaints really about the Masso, and I feel like if I like got another machine that didn't come with one, I'd probably want to put it on there. Maybe just because I'm used to it, but I don't know, something about not needing to have a dedicated computer for the machine I like. And even just from like a file management standpoint, if you had to have like every single file in your little handheld like Game Boy type pendant, and like make sure you're calling the right file for whatever, like I don't know, I wouldn't particularly enjoy doing that, I don't think.
Yeah. But I have one machine that has a visual representation, and I found that that's helped me avoid some dumb errors.
Yeah.
So that's a really
Yeah,
nice.
even just like if you like, it's happened to me a few times. I mostly just use G54, but like if you are somebody that uses multiple work coordinate systems, then like if you're accidentally in the wrong one and you've set your 0 in the wrong one, and then you hit cycle start, it's not going to use the one that you just set wrong. It's just going to use whatever the code says to use. So if you can see, and that happened to me once actually. I've not knock on wood, have not like destroyed a finished body yet, but I have almost done it. And it was one of those cases where the G54 was off a little bit, or I'd set G55 instead of G54, and the spidey sense was tingling when it was going to do that first helical ramp into the finish, and I just hit and I'm glad that I did, and probably wouldn't have noticed if it weren't for the visual representation. So
Yeah. Uh, we've had you for a while, but real quick before we open it up for questions, doing your pickup routes and things after the finish. Can you talk a little bit about bits and your choice of bits? Because I imagine that's
Yeah.
critically
Yeah.
important.
Yeah, you don't want to throw an upcut in there right off the bat. I would, yeah, generally like with the post finish stuff. Other than the when you get past the just like needing to know exactly where the part and the fixture are, and like you feel confident in that, like the actual machining of it is not it's not any harder than doing anything else. I would say really you need to have a sharp down cut, sharp spiral down cut bit, and I I usually just use a 1/4 inch down cut, and uh, I what I should do is put a notch on the case every time I use it, so I keep track of how many finished bodies I have run. But I don't do that, um, and I just sort of like I think like I use a 1/4 inch and then I use a 16th inch down cut, and the 16th inch ones I usually toss after like 2 or 3 guitars, just because they still work, but you really need it to just be you just need it to be crazy sharp.
Are you using downcut for the entire operation, or are you switching?
No, so what I'll do is like I and I do all of this in cam, and I'll just like like so let's say for the pickup routes, or I guess any of the routes, like I'll maybe do a 1/4 inch depth. Um, so just like a pocket operation at a 1/4 inch depth, and I'll use a negative stock to leave to offset to basically make the pocket bigger by a specified amount. So
So the flutes on the following bit are not coming in contact as it goes.
yeah, exactly. Because I mean, you could do it all with the downcut. I just am not like I know people that use downcut bits for a lot of things, and I'm really not. I don't really like. I don't like them for a lot of things, but they're kind of the only thing to use for this. So, um, my favorite bit to use for like just about everything uh, is just like a 1/4 inch O flute. So when you're used to just getting that kind of like chip size and chip evacuation with those, like you got to change your programming a little bit for downcut stuff. But yeah, so I'll usually offset the pocket by maybe I think like -5 thousandths. So the whole it's 5 thousandths all around. So if you were measuring one side to the other, the whole thing's going to be 10 thou bigger. But then yeah, you basically then I'll come back with an upcut, and just to save time, change the starting depth to a 1/4 inch below the top of the model, and just make sure that you didn't like duplicate that operation and leave the negative stock to leave in there.
Yeah.
And I don't know, I like doing it that way too, because like I did something with like took some gold foil pickups that were not really body mount, or like that were body mount but not height adjustable, other than like using a shim. But then you can get such a precise fit that I could make a riser and have screws and springs and actually have it be adjustable. So it's nice for that kind of stuff too, where you want to get a really close fit with some hardware or some pickups or something like that. And then yeah, the other thing that that helps with the post finish stuff is or that I like to use it for is using brass threaded inserts for the pickguard screws and stuff like that. And you could mark those holes and drill them, I guess, with like a sharp brad point bit. But I don't know. I'd be more scared to do that than I would just doing them on the CNC. And I just use a 16th inch downcut and just interpolate the holes. And then the same thing for like bridge mounting screw holes or something. Like I will still drill those post finish. But I will like relieve the top of the hole by, let's say like on a Telecaster bridge, the 4 mounting screw holes. I'll do a boring operation that, relieves the top of the hole for that unthreaded part of the wood screw that is typically like the, a little bit bigger than the
Major diameter.
than you need for the pilot. And then I'll just come in afterwards and hope for the best with an 1/8 inch end mill to drill the rest of it. Little bit of compressed air when you're doing that helps just to try and get get the chips out of there. But yeah, that's really, I mean, I feel like the machining itself is pretty straightforward. It just, in order to feel confident doing that, you need to really know your machine and know what it's going to do. Like before I ever routed into a finished guitar, I did make like a dummy body, and I ran all of those post-finish operations first. Just on an unfinished guitar, just to see, make sure that, kind of prove that tool path on something that the stakes are a little bit lower. And then the other thing, for the threaded inserts and stuff like that, or really any sort of fitment stuff, like I would highly recommend anybody, going back to knowing your machine and knowing your setup and stuff would be like, I've got all various lengths of, steel dowel pins and stuff, and nylon rod and stuff that I can just cut to whatever length I need. And it's really handy to know from a programming standpoint, if you don't always want to be stuck with whatever size bit or size collet you have for like what size holes you can make. So if your machine is tuned up and you don't have you don't have a lot of backlash and stuff like that, or you're compensating for it, you can get pretty accurate interpolation of holes. So using a smaller bit to make kind of any size hole. And I do that a lot. So what I've done, I did this only once or twice, and then you just write it down or remember it, where like, you in the CAD or something, or model a bunch of holes in a piece of scrap wood, like whatever wood you use a lot. Like, so I would have done this in roasted maple and acrylic too, and you kind of see how different materials behave. But just like, okay, I'm going to do a bore operation on this hole and have it machined as the actual size, and then I'll machine with, negative 0.5 stock to leave, and then I'll do negative 1,000, and then negative 1.5, and negative 2, and negative 3. And just a line of them, you can write it down on the piece, and then you just check the fit with your pins and just find the one that fits best, and then that when you're programming, even if you're doing it in a guitar that's already got lacquer on it or whatever, that you're not going to be worrying that your stuff's not going to fit. So it helps to do that kind of stuff too. So you just know that you don't have to do a bunch of test cuts for every little thing.
Yeah.
I think the finish that you get is really, worth. I think the results that you get are really worth cutting through the finish. I actually did it for the first time just by accident, because I realized my design was not the right one. I was putting in a block, for the string through, rather than, cutting the individual. So after it was finished, I realized my mistake, and I thought, well, okay, I can, cut through the finish now. I just have to be really, really careful. And once it was done, I told myself, wow, that's really nice. Why aren't I doing that with all of my cavities?
Yeah. And one thing I would point out too about like fit routing, I mean, it's one thing, throwing it on the CNC after or whatever, but like in shops all around the world, people are putting humbuckers in single coil pickup guitars with a hand router in a finished guitar, with a straight flute router bit. And they don't, I personally never had a finished chip on me doing that. So it's definitely, the wild card in there is the CNC machine and not being able to like physically line up your template on a center line or something like that. But I haven't tried a straight flute. I imagine a straight flute would probably do okay for post finish too. But yeah.
Oh, that was great. Is there anything that you think we've missed that you find critical to your workflow?
Yeah, I mean, I think maybe like the only thing that I think maybe unusual is that the way that I do things is just as far as like how I make the necks. But I mentioned a couple times, but I like to glue the fretboard on before I do a lot of the extra machine, like the additional machining and stuff. So that's maybe something.
So are you doing the profile and then the fretboard and then doing the profile again? What's the
well, so I take this approach with a a thin line body or something where I'm gluing a top on to something as well, where like I don't really like sanding a glue line, and when you have a bajillion clamps holding something down, it's really hard to clean up, squeeze out effectively too. So I like to try and just not have to do that. So usually I'll the I guess one thing I didn't really touch on, but for I think is pretty helpful. I found it helpful is like not getting the CNC to like do all of the heavy lifting in terms of like cutting profiles and stuff. Like, so I'm never I like to use a 1/2 inch tool for all of my profile stuff, and I like to do it at full depth of cut. Which like if you were doing full depth of cut around a body that you hadn't cut out yet, like that would be pretty terrifying, I would think. I definitely would not advocate doing that. But if you're doing like a 1 3/4 inch depth of cut with a 1/2 inch tool, and you're only taking off like 10 thousandths or something, like that's cuts really nicely. So for necks or bodies or anything, like I've made jigs like this with drill bushings in them. And I'll line it up on the part so I can actually see the grain and orient the grain the way that I want, or line up on to a center line if it's like on a glued up body blank or something. And then once I've drilled the holes, I'll draw the outline around it, and then I'll just cut the waste off on the bandsaw, and just cut as close to the line as I can within reason, and then doing the rest on there. So for a neck, the holes get hidden under the first and last dots. The 3/16 hole and the dots 1/4 inch, so there's room for things to kind of evolve a little bit throughout the process. But the neck goes face down. I cut the outer profile and I leave a 32nd of an inch of material all around. But I'll machine the index features on the back of it, and then I'll flip it over, cut the truss rod channel, install the truss rod, and then glue the fretboard on. And there are like kind of Lego type index features for that, just to keep things from sliding around in the glue up. And then before I carve the neck profile, and this is after the fretboard's glued up, then I will do the final outer profile, and then that takes care of the glue squeeze out and any like little bit of misalignment where you've glued up the fretboard. And because it hasn't been slotted yet, it doesn't really matter in that sense. And I would do the same thing with the a thin line guitar body or something where the pre-glue up operations are leaving some material that then once it's all glued together gets shrunk down to final size.
And in our conversations before, you were talking about how you you do your final radius and relief on the CNC machine.
Yeah, I guess that, yeah. And I mean, I'm still always messing with that a little bit, but because I started using single action truss rods as opposed to dual action, and while that is I quite like it. At least the necks end up being a bit lighter, which I like because I'm always kind of chasing the lightest guitar I can have, and I do like a compression rod as opposed to dual action rod that's just kind of putting pressure up or down on the middle of the neck. I like that the compression rod is kind of putting the wood under tension in a different way. But then obviously what anybody that done any fretwork knows that a single action rod, you got to be pretty careful about how much relief you have or don't have after you've done your fretboard prep and stuff. And I don't really like to I try to get my frets installed so that I don't have to do any leveling either. So I, through trial and error, like sort of drew up the relief that I wanted to see in the neck and machined a few necks and fretted them, strung them up and stuff, and landed on some geometry that works for me. So I machine that in as the very last thing that I do before I get frets in the guitar, and then using that rig that Ian posted to Looth prints with the sliding radius block. I made up my own more permanent desktop version of that rig, and now I'll take the neck off the machine, having just machined the relief in, and I'll take it over to usually let it sit overnight after I machine it, check to see if it's moved at all, and then tighten up the truss rod, straighten the neck out, and then I just start sanding with 180 usually, and usually have the neck ready for frets in under half an hour. So it's pretty efficient that way. And then putting relief into a neck that doesn't have it is fine. I just got tired of having to do it every single time. If that's something that every time I make a neck, I'm doing that, and then it's hard to do that the exact same way every single time by hand. So I sort of did the poor man's plec kind of thing, and just have one version of this relief geometry that I like, and has been working for me, and just do that. So and I wouldn't be able to do that if I didn't machine that after the fretboard was glued on and the neck was carved and stuff. And even something as small as one thing I changed just recently was that I'll machine the fretboard surface and leave 10 thou of stock or something, and then I will cut the fret slots. And I've checked at and so even that rough in of the radius has the relief in it as well. And so I've taken it, I've measured it at that stage with feeler gauges while it's on the machine, and then turn the vacuum source off, measured it at that point, then take it off the machine, measure that, and then cut the fret slots. And the fret slots basically negate the relief. You cut 21 slots into a piece of wood, you're exposing a lot of end grain there, and as far as I understand it, end grain absorbs the most moisture. So why we wax the ends of rosewood boards and stuff like that. But so what I found is I'll rough the radius in, cut the fret slots, and then machine the radius one more time after I cut the fret slots. And by doing that, I've been getting, I'll come back the next day and have the same, like the amount of relief I wanted to have. But I was fine. It happened by accident once where like I accident an inlay didn't have enough glue and it like shot out or whatever. So I had to glue another one in and machine the radius again. And I noticed that it seemed to be machining more material than I was expecting it to. And lo and behold, it was, because the neck sort of, you know, did this a little bit once the fret slots were cut. So
Interesting. Yeah.
whenever, you know, it's not the most efficient way to do it, but or, you know, not the most time efficient way to do it, I guess. But I feel like the extra time I take to do that makes the prep for frets a lot more predictable and take less time. So, and you know, going to all of those lengths so that I don't have to level the frets once I put them in, that also saves time too. So I'm not like leveling and crowning and doing all that.
Well, and that actually explains to me, because at first I thought it's like, wow, he's really anal retentive about the accuracy of it. I was like, it's wood. But yes, when you're doing, you know, little activities like that, you know, then accuracy becomes really important.
Yeah, totally. And it going back to what I said before, it kind of comes down to like, if you're, you know, pathological about it, like I am, and you just, you know, you're using it for every little thing, then, you know, it helps to put in the time, just so that you know that if you're having an issue, that it's not the machine, because there's a lot of things it could be. It could, you know, not every neck responds the same way when you machine relief into it too. So sometimes it, you know, just one piece of wood to another is a little bit different. But because I use it for so much, I like to know that the machine is not the problem, because it's easy to like blame the machine.
The robot.
Yeah.
Yeah. Well, we've had you for looks like an hour and 45 minutes already. I think at this point, thank you. I'll say thank you before.
Yeah. Thanks for having me. I hope that not everybody is asleep, because when I get going about this stuff, it often results in narcolepsy. So
Well, no,
I'm excited to finally hear somebody crapping on dual action truss rods for a change.
Oh, really? Are you?
I'm against them.
Yeah, I mean, I definitely, with stuff like that, I it wasn't until I tried it and I'm not so sure that if I would have done it on the first few guitars, like used a single action rod, I would have known the difference. But when I built, you know, 20 or something, and then did switch to a single action, and then actually just I don't generally poo-poo things that I can't like tell the difference myself in a measurable way, and it really made a difference to me. So I don't know.
Yeah. I think they get sold because people are afraid of cutting a weird slot. You know, like the double action truss rod slot, straight down the line.
Yeah.
You're like, all right. Plus, it's got two actions.
Yeah, and I mean the amount of like 3D printery and whatnot that I had to go through to be able to do the single action rods in a way that I felt like was clean and working the right way. It was not a trivial amount of work to get that done. And what took me so long, I think, to try to go down that road too, is that there's not a lot of great information on how to do that. At least for like a Fender style one, there's a lot of dudes saying like, just drill a hole in a piece of maple at an angle and then just like clamp it on the drill press or whatever. And like having heard me talk at length about, you know, dry stuff like this, I'm sure that you can tell that when I read that, I thought like, there's got to be a way that I can spend like a year trying to figure out how to do this in a way that doesn't make me want to, you know.
Well, I would imagine Fender probably did theirs on a pin router. I would think with that like a
Yeah. I mean, the curve slot is definitely. I mean, that was a bit of a thing where I experimented with some different radiuses, radii with that. And that was one thing that I did find a little like I really don't like spending a lot of time on guitar forums, but that was the only place I found any information about that was on a forum, and it was actually not bad information just with regards to like the sort of let's say from the middle of the rod to the ends, like the maximum or minimum distance that you would want. And I've noticed on my one piece necks versus two piece that they respond to truss rod tension differently, even though like the curve is the same. It's I think it has to do with maybe the anchor or something. I'm not really sure, but yeah, it definitely,
We haven't really done anything on truss rods. We should do a truss rod roundup because that those installs are interesting. Just the way they work is, especially the below the center line truss rods, like that's real counterintuitive, I think, for a lot of people.
For my vote, I'd be really interested in something like that as well. I'm currently trying to make my own truss rods, but I'm caught between which designs to use, which will affect how I build them as well. So
yeah. Well, one thing that I find a little bit annoying about them is that because the neck is under tension and you've got, you're basically putting a straight rod and forcing it into a curve, and then it kind of makes the whole neck want to go into an up bow at rest, which like is annoying for me just from a machining standpoint and stuff. But I've tried also like pre-bending the rod, and it's hard to do that in a way that doesn't feel like it makes you need to put more tension on it to get it to actually work properly. Because if your pre-bend of the rod is not exactly matched to the radius of the curved slot, then you're sort of like needing to put more tension on just to get the rod to kind of put pressure in the spot that you want it to. So
when you're looking at the curve of the rod, it's always good to keep in the back of your mind that Gibson rods were curved backwards and they still work.
Curved backwards.
Gibson rods were curved opposite how logic would say they should be, opposite how Fender rods are. You look at all the 30s, 40s, 50s, and they actually are curved completely backwards, and they still work just in their position.
Okay. And so are you saying that the slot is cut the opposite or the rod? Yeah.
Yes.
Okay.
The slot is cut opposite, so it actually curves opposite. So the straightening of the rod is fighting itself.
Okay.
The curvature of the rod is trying to push it into more relief, but because its overall tension is toward the back, the tension weighs out, so it fights against itself. There's people who believe that increases stiffening effect. I don't know how much that's true, but
wow, I didn't know that. Thanks for telling me that. That's cool. That's gonna send me down.
I think John Thomas, I think, has some good X-rays of. He did a bunch of X-raying of some old 40s Gibsons and has some of those. And
so did they not have a filler strip in there then?
Yeah, they have a filler strip, but it's very tall because they cut so far toward the back and then curve down extra at the heel.
Oh, okay.
The anchor down there, but
right, yeah, I see what you're saying. Okay, yeah.
Even on like their mandolins had a curve that was fairly extreme in
right.
That's why you never reshape a mandolin neck from many of those either, or a guitar neck.
Yeah. Yikes. Yeah. That's really interesting. I've heard of people saying that the rod itself or the slot itself doesn't need to be curved if the one end is higher or lower than the other. And I didn't really fully understand.
At Gallops, we always just did dado blade. It was just a straight dado.
Okay.
It was curved slightly because the anchor at the under the nut end did rise that up slightly, but it was only curved in the first few inches from that effect.
Okay.
It was a straight dadoed slot.
Interesting. Huh.
But I'm sure you could go on studies, and you seem the perfect person to dive into this rabbit hole of figuring.
I know, it's just exactly what I need, I think, is just like something else to Yeah.
Lewis, so you not cutting it with like a channeling bit on a router table? You're cutting it on the CNC?
Yeah, I do it on the CNC. So I use a 1/4-inch O flute tool, like a single flute tool, and it can take a really big chip. I basically, you got to use the trace toolpath, which follows the 3D of the curve, and yeah, it works well. It's easier because then you don't have to worry about like stopping it in the right place, and like because I machine all my skunk stripes like 20 at a time or something like that, so just helps to be able to have that in a pretty consistent and it also helps too because I can see then once I've drilled the holes like on a one-piece neck to go through from the headstock, that if the slot stops in exactly the right place, then you can see if that hole is coming through at the right place too.
This is how I always imagined them cutting it, is with one of these bits and the neck mounted sideways and then pushing, having some big sled that you push into the cut.
Right. I guess the only thing would be like the shape of the end of the cut. What would the shape of it be? It would be square or straight, I guess.
Well, you'd be going out one end.
Oh, if we're talking about like a two-piece neck, I guess. Yeah, that would work like that. And that's sort of like what I was saying before. And I think I've heard you say this too with regards to shapers and stuff, is like, there's like a lot of stuff that I do with this that like if I, had the, desire to just like make a bunch of shaper jigs, like somebody could stand there and just crank them out all day long, way faster than I could do this. But I almost lost my hand in a shaper. I like a few years ago had the only like non-Loothing job that I've had in a while, and I worked at a kitchen cabinet shop for like 3 months, and I was coping the end of like a really short rail for a cabinet door, and had the clamp on the sliding table jig and was holding onto it really, really tight, and the thing started to get pulled into it. And the guy who I was working with just happened to be standing next to me and shut the shaper off at the right moment. So every time I think about shapers, I think like maybe not, but
yeah, no, they're hell on wheels for sure. Okay, I showed up late, and then I'm keeping it even later. So let's everybody unmute and say thank you to Lewis and to James.
Thank you.
Thanks, guys. Appreciate it.
Thanks for having me, guys.
Absolutely.
Thank you, Lewis, for spending the time with us.